So yeah, today I'll be presenting on Infrastructure 2050. I could not possibly do that without spotlighting ASCE 2050. Based on a lot of the feedback in this call, I might assume that a lot of people are familiar with ASCE 2050. So I'll just kind of jump right to it. But ASCE 2050 is the structural engineer's commitment to reducing embodied carbon in the structural system by 2050. They have this really great statistic showing about half of the structure accounting for the embodied carbon footprint, which will just kind of set the stage. And I might have some more elementary graphics or notes herein, but I just also want to make sure that everyone's aligned on the same page for the workshop at the end. So we do know that the structure is a significant part of the embodied carbon of the building. And that also leaves the question open about other infrastructure systems. So bridges, tunnels, roadways, really understanding the emissions associated with that across each of the different life cycles. So A1 to A3, A4, A5, and B1 to B5 on the end stages. We also know that America's infrastructure on the ASCE report card is a C-. And I think this is really important. There was a statistic from the United Nations that mentioned about 3/4 of the infrastructure we expect to have built by 2050 has yet to be built. So really interesting to see how much work has yet to be done, the current rating or grade of our infrastructure. So just kind of jarring to think about how much embodied emissions we will anticipate emitting in the next 26 years. So this is really where Infrastructure 2050 was born. So it is following right in the footsteps of ASCE 2050. We closely work with their team, and it's just the pledge in a different light from buildings, where the pledge to work with infrastructure professionals to understand, reduce, and ultimately work to eliminate embodied carbon. A little bit of the difference is that it's not only structural engineers. So there's so many stakeholders that are involved in this process, whether it's the clients, research institutions, industry organizations. And while we're trying to follow as best in the footsteps of ASCE 2050, we're also kind of taking a different angle and expanding that circle, which is really exciting. Because there's so many different focus areas, right? It's not solely a building structural system. So it could be a bridge, a tunnel, a roadway, a highway, aviation, ports, transmission and distribution systems. So a lot of different systems to start thinking about. So kind of to the point that Dan was talking about, it is very difficult to start thinking about what a database should collect. And we don't want to publish something before we know what that database should look like, because you're then asking the industry to go back and make changes to the data, which can be very, very difficult. So we really want to make sure it's as thoroughly thought out as possible before kind of launching something. So what we can kind of reflect on, again, really great resource from the Net Zero Bridges group based in the UK. They have this typology of different categories of how we can start compartmentalizing different components of bridge systems, whether it's by use, the extent of works, if it's a new build or a bridge widening, maybe it's the structural system, the beam, truss bridge. All of these are very important to think about the primary materials. And like Dan mentioned, the foundations is key. So that's another one. Now, the question that comes up is when we're thinking about buildings, it's that global warming potential intensity. So for infrastructure or for bridges specifically, is it per square foot of the area of the roadway? You know, we got to classify if it's a vehicular bridge, how many lanes does it have? How do we want to start comparing apples to apples of different bridge types? Overall, this is the vision that ASCE 2050 has, and this is some of the really great work that they're doing as well. So they're basically saying, you know, the red on top would show whether it's a school or different types of buildings, a hospital, residential. And we have the very same vision for Infrastructure 2050. So is it a truss bridge, a tied arch bridge, a cable stayed bridge, all different infrastructure systems, ultimately working towards the goal that Dan's team is also doing similarly. That's the global warming potential intensity, right? So eventually, can we draw some line in the sand that says, you know, to the industry, here's that recommendation of what you realistically can be under. And the more data that we do collect, the more advantageous it will be to help promote that and drive effective policies. So ultimately, infrastructure, it is very, there's a very wide variety of infrastructure types. It could be bridges, tunnels, right? But ultimately, we really want our group to be this centralized infrastructure knowledge hub. And that will drive environmentally conscious design decisions that will help spearhead effective policies. We can really standardize that methodology for carbon and infrastructure systems and establish those baselines and targets. I do want to call out that ASCE does have Standard 73. So this is the Sustainable Infrastructure Standard. It is a great place for us to build on. On the left side, you can see what the current language kind of alludes to, and the right side is what we're already thinking about the next version. So, we're really introducing the group that developed Standard 73 at ASCE. They were really introducing embodied carbon. It's more qualitative in the first item here. So identify your embodied carbon reduction strategies. Great place to start to help people get in the swing of things and help engineers understand how to think about this. And in a future version, we really want to be able to require users to follow some standardized methodology to help calculate emissions. So the point Dan was making, in a consistent manner across the industry. That's key. And if we work together, this will radically accelerate that process. We're also hoping to require users to benchmark their projects against these industry baselines once we do understand what the responsible recommended baseline would look like. Also, they are requiring users to follow Type 3 EPD data, which is fantastic. We know this. But there's another number of other life cycle stages that we do want to think about. And so we're wondering if we can require users to follow specific guidance for those stages beyond A1 to A3. So Infrastructure 2050, some background, we are working with a number of incredible organizations. This is the ECHO project. So we're really excited to be working as part of that. We are learning a lot because it is so focused on buildings right now. There's also landscape architect professionals. I'm thinking of climate positive design, and then infrastructure and Envision ISI. So really trying to learn how infrastructure standards can be harmonized and leaning into the ECHO project a lot. So this is a tunnel case study to just kind of shift the gears from what Dan was speaking about. And I just kind of wanted to start, great graphic from Carbon Leadership Forum, breaking down the different stages. And then what I did is I overlaid some data from RMI. So this is really buildings focused. And we know that, if it's 65 to 85% is associated with A1 to A3, A4, A5 shows 6 to 10%. I've seen some articles that say, is that really 20? Is that really 30? And they're all really focused on building designs. But the question that we have with infrastructure is, what is that actual footprint in the other life? How is this broken apart? Should we really be looking at operations and maintenance more closely, especially for systems like bridges? Maybe a tunnel has less operations than maintenance in terms of the structure itself. If it's like an underground roadway, maybe this is supposed to be watertight, so it really shouldn't have as high of an embodied emissions footprint for B1 to B5. So really trying to understand where the heavy impacts are happening. So this was a study from the team is at the top of the screen here. They were doing this case study on sustainability of underground infrastructure. I really appreciate this because this helps us go from that 65 to 85% and, 6 to the product stage, and then 6 to 10% of A4 to A5 for transportation and construction. We can actually see that the split here is not as significant of that of a building. So we can see the lining is a massive component of this, and we can see the tunnel boring machine has a significant energy associated with it. So I think in total, this footprint was around 32%. On the screen we just saw before, it was showing 6 to 10%. So we can already see that the construction of a tunnel is significant, especially with that, energy usage of the TBM. I really also appreciated this case study breaking down in the Sankey diagram the different components. So we know that concrete, steel, asphalt, glass, these are high emitting materials, but the precast industry, we frequently hear that it's behind in terms of getting the EPD data. So with precast liner, we're experiencing similar issues. Is what is the EPD for this precast tunnel liner? Because a lot of times you might have to just do calculations based on your quantity estimates in order to understand the concrete, the rebar, but is there an EPD for the assembly itself? You can also see materials in here like grout. There's not a lot of, I'm thinking about EPDs with grout there. I would say it's more difficult for us to locate. So all these different materials, we really want to accelerate how many EPDs are available in the industry to make sure that this is more rapidly adopted. It's really helpful that you can see A4 as a sliver here, and then A5, again, that tunnel boring machine, and then significant impacts with spoil removal. Again, I really appreciate this case study. They make it very clear about what data goes into these calculations. So I'm always curious, how many people joining these calls have done not only the analysis of embodied carbon, but have actually done the calculations, because it is very time consuming. You're trying to determine your baseline scenario. Then you have to move to your actual design targeted reduction scenario. And then you have the construction phase where you're trying to track actual, emissions associated with that. So lots of different stages, lots of data needed, lots of emissions factor that, trying to figure out which one's the right one. And this really paints a very clear picture of all the different data that you might want to start thinking about when doing an embodied carbon analysis. So this is just kind of summarizing that. And I think it's really important to highlight one of the stakeholders being cost estimator. So if you're at your firm and you're trying to start doing embodied carbon analyses, make sure you're connecting with the cost estimators, the material quantities, the equipment estimates, the fuel usage estimates, right? These are all really valuable pieces of data that you might already have in a really streamlined manner to start analyzing. So it's really important that we start connecting with that stakeholder as well. It's not only the designers. Material production, this is, GWP from your EPDs, reasonably straightforward. And then you start thinking about your transportation to site. You have multiple materials, maybe from a single vendor, trying to figure out how you're creating the methodology to calculate A4. Thinking about A5, again, construction equipment, what data do you have available? What can you start calculating and how are you going to put that together? And then the maintenance and repair. So this one, are you thinking about the lifetime of your asset? If it's 100, 120 years, and maybe a specific material has a lifespan of, 50 years or something, what amount of materials will it take to repair and replace that system? And how many times does that happen over the lifespan of that asset? This is a very complex calculation that we have to start providing more clarity to the industry to help them understand how to perform this and rapidly accelerate these calculations. So I know we're coming up to less than 20 minutes right now. I think it would be really helpful to kind of have this open forum discussion with the group. I have some questions that just come, immediately to mind, but some of the areas where we're seeing opportunities with Infrastructure 2050 is significant areas with researchers, right? So, how we can start analyzing system designs. What's that optimal balance between a resilient system that's durable and considering climate projections, and also considering low carbon systems, right? How are we working towards global warming potential intensity baselines by infrastructure type? Materials, low carbon grout, those precast tunnel liners, this is huge. We see the industry gap. How can we help accelerate that? By clean policies, we know some states have, for concrete or steel or asphalt, some of them don't have concrete. So how are we identifying the gaps in policies and understanding the amount of materials used in each of those states, or the projected amount of materials needed for the next 26 years, and really tackling those heavy emitting areas. Again, these are just kind of to try and get everyone inspired about, what we can start talking about in this open forum. There's also questions about measuring progress by stakeholder. So as an initiative, again, there's so many stakeholders. You have the policies at the top, which then inform the agencies. The client can really be making, a lot of decisions, but sometimes that is based on cost. So what do we need to do as an industry with all of the other associated stakeholders to more radically advance this? Engineering software, I'm thinking about modeling. How can the tools that we use be upgraded to make sure that more access is provided to just simply connect EPD databases to our modeling tools? How can we work with the cost estimators? So lots of questions focused on cost estimators, but also equipment manufacturers. What do you do with a fleet that you have, maybe a full diesel fleet, and you're starting to think about these targets, and how do you transition? So I just kind of want to, maybe we'll narrow it in a little bit. Maybe we'll kind of talk about what Dan started with. So Dan, you guys are doing this embodied carbon, you've built this embodied carbon database at your firm. And I think it would be really helpful. I mean, I have the scores for bridges on the right side that, your team has kind of compared against, but, you mentioned a lot of issues or concerns or challenges really with figuring out what the KPIs are, what data really should be collected. So maybe we can just kind of learn a little bit more about maybe what you see as some of the gaps. It sounds like you mentioned the foundation system being critical. What recommendations might you have for the industry to help accelerate towards these global warming potential intensity thresholds?
Yeah, thanks, Lauren. I think it's a really hard one. The more varied the typology, the much harder it is to have a reliable threshold. So we're using some related to this scores one, and I was just responding to a question in the chat there about average intensities for different bridge types.
Yeah,
And this scores one has this is for all bridges without variation on the bridge type. Um, but there was a study which looked at the difference between pedestrian and road and rail bridges, and pedestrian and road bridges are quite close, but rail bridges are significantly higher on the threshold. So um, there's a desire to simplify things so that we can use them as useful tools in the
yeah,
design stage. And then there's I think that's really encouraging, but we should always be aware of the challenges of oversimplifying it and understanding that a grade E maybe for some scenarios isn't bad if you're on the foundations of toothpaste and you've got this crazy span, and it's for a railway and things. So one thing that can do is maybe make you reconsider whether a bridge is a good idea in some of these sites. But the developing these thresholds needs to be aware that they're not necessarily hard lines. They're
yeah,
design inputs that we can use. Um,
absolutely.
in terms of KPIs, I think one thing which is interesting for us, so just like Bergman Partner, we also work on buildings and other types of projects, not exclusively bridges. And something for buildings that we're thinking about is if meter squared is a good way to normalize things. Some buildings get used very infrequently. Apartments in Germany, say, have a smaller average size than an apartment in the US. Is meter squared a good metric, or is per person use a better metric? How many people can live in a building? And I think similar arguments can be made for bridges.
Yeah,
Does it depend on the traffic more than the area? Does it depend on how should we really be taking into consideration how much a bridge might shorten a vehicular route as part of that assessment? If it cuts off a 1,000 mile detour, then maybe if it's a really challenging site with really high per meter squared bridge intensity, that may be totally irrelevant compared to the overall emission saving that can be made. So I think I'm really interested in how we can think about some of those use metrics instead of area metrics more, although I don't have a good answer for that at the moment.
no, but that's exactly how we should be, brainstorming. That's so valuable. Thank you so much for that. I was thinking about how in one of the bridge focus groups in the very beginning, it was really a lot of questions about, well, what about the vehicles driving on the bridge? Or what about where the bridge is located? And some of the challenges that if you focus on, following the footsteps of ASCE 2050, you focus on the engineering aspect. A lot of times the agencies have already determined the location of that bridge, right? So you might have some flexibility in specifics on site, but that planning level effort has potentially already happened and you don't have flexibility as some of the feedback that we've heard. So, as an engineer and as a bridge designing engineer, using what we can do to make low carbon informed decisions might be restricted in terms of that planning level consideration. So that was something you made me think about when you mentioned that. And then, I also was thinking about in one of your graphics, you had showed construction and, included within your visual. And I was kind of curious how, with A5, how is your team kind of assuming or estimating that value for each of the options that you're looking at? I think it was in the concept stage. So, you might be saying this many months, this much equipment, these emissions factors, and here's the estimated. Is that kind of the process that you're using internally?
Yes, I mean, depending on the project, we'll do it. We'll do a much worse job of it, and potentially make broader assumptions on construction cost or construction area, um, without being able to get into the details of what we think will actually happen on the construction sequence and things. And that's, I think, from our take, one of the biggest sources of variability in how we can do this. And also the difference between what the designer can control and what happens once it's gone for bidding, and getting uh, different ideas from contractors on how they would build it and what their process would be. So I think this temporary works and construction emissions are something which I think we're generally lacking a lot of in the industry, and or definitely lacking guidance for people to use on those. So we're also missing some of that. And construction temporary works in particular, I'd say need to be taken with a grain of salt in terms of how that's used and compared. If the bridges that we're comparing at option stages the same site with broadly similar budgets and planned schedules, then maybe that's less important. But if you're comparing across projects in a database, it becomes really, really hard.